Today I'm going to be discussing a retro system that I've been working on for quite a while, and the main reason for this is pretty much due to the sheer expense of all the individual components involved, and I've had to import all these components individually, so that's taken up quite a bit of time and money. Taking a look at the system slot arrangements, the bottom ISA slot is not populated at this point, but I may find a card to slot into the slot in the future. The next slot is fitted with the AWE64 Gold sound card, and this card is fitted with a SimCon Revival memory expansion device, giving it 32 MB of RAM. The next ISA slot is slotted with a 3COM Etherlink 3 ISA network card. Next we have an Adaptec 2940 ultra-wide SCSI controller card, and this controls the SCSI CD-ROM fitted in the machine. Next is the ICP Vortex SCSI RAID control card, and this card is fitted with 64 MB of write cache and controls the two system drives which are in a RAID 0 configuration, and this at the end of the SCSI cable is the termination device. The next slot isn't populated in order to give the Voodoo 5 some breathing room, and the USB header is also found in this space, and I will be fitting a USB expansion device at a later stage. Next we have the Voodoo 5 itself. You can see the additional power coupling required by the card, and you can also see that the card is fitted with the additional DVI port. Next we have the system memory, which consists of 192 MB of EDO RAM. Next we have the Pentium 2 Overdrive chip in all of its glory. The system is powered by a 450 watt ATX power supply. I still need to figure out the pinout on the front panel connector in order to couple it to the header on the motherboard. Now that I've got the system up and running, the first thing that I'm going to do is run CPU-Z to show you how it sees the system. It shows the CPU to be a Pentium 2 Overdrive in a socket 8 motherboard. It's running at 332 MHz and has 512 KB of level 2 cache, which is running at the same speed as the CPU. The motherboard is a Chaintech 2A69HC39C, and the BIOS has the date of the 10th of the 11th of 1996. The system has 192 MB of EDO RAM installed, and these are the timings. It detects the GPU to be from 3DFX, and it's a Voodoo 4/5. I'm now going to make use of CPU-Z's benchmark facility in order to compare this CPU to that of a Pentium 200mmX. Here you can see that the CPU is significantly more powerful than a Pentium 200mmX. If we take a look at what we saw in the last video that I made before upgrading this machine, it also shows it to be significantly more powerful than the Pentium Pro 200. Next I'm going to take you through the device manager to show you the various devices installed. The system is a standard PC and has the name Overdrive. There is a host SCSI disk device as well as an iOmega zip drive installed. There's a Voodoo 5 5500 PCI/DVI graphics card installed. There's a Samsung CD rewritable disk drive as well as a Toshiba SCSI DVD-ROM installed. The system features a standard floppy disk controller and has a floppy disk drive installed. The system features the following IDE controllers, and the only IDE device in the system is the Samsung rewritable CD-ROM. The monitor is a default monitor. There's a 3COM Etherlink 3 ISA network card installed. There's an Adaptec 2940 ultra-wide SCSI controller card installed, and this controls the Toshiba SCSI DVD-ROM drive. There's a SCSI array controller installed, and this controls the host SCSI disk device. There's an AWE64 Gold installed, which is Sound Blaster 16-bit compatible, as well as MIDI wavetable compatible. The storage volume is a generic volume, and it's controlled by the SCSI array controller. Finally, the system has a USB universal host controller as well as a USB root hub installed. Next, I'll show you the system's drive performance by opening up some rather heavily loaded folders on the system drive. The Win32 folder will be a good test. Not too bad for a system of this vintage. Next, I'm going to run the Atto disk benchmark to give you an idea of the disk's absolute performance. This was a good result, however I have seen better performance from this disk, so I'm going to run the benchmark again. In this run, there were moments where the disk offered superior performance when it reached 70 megabytes per second. However, there is a degree of inconsistency. So I'm going to open up the system performance monitor in order to see if there's a problem with memory, if memory is not the reason why the drive isn't performing correctly or consistently. So I'm going to run the benchmark again with the system performance monitor open to see what happens with memory and CPU usage. You can see that the drive's performance was reduced slightly by having the performance monitor open. However, when taking a look at page file usage as well as memory usage, there's no indication that memory is the reason why the drive isn't performing consistently. Let's quickly take a look at how this drive's performance compares to that of the previous drive setup that I had in the system. As you can see, the previous drive was a lot slower, however it seems to be far more consistent though. Next, I'm going to show you the system's performance when running Quake 2.
Thermals indicate possible camouflage access in wet sector 430.
These are the settings that I'll be using for the test. I'm going to run a time demo test to show the average FPS that the system achieves when running Quake 2 at these settings. Not too bad for a system with a Pentium 2 Overdrive at its core. Next I'm going to show you the system's Quake 3 performance. I'm going to be making use of the following settings for this demonstration. I'm going to start off by playing the first level of the Quake 3 arena just to show you the system's performance during normal gameplay.
Ranger. You have taken the lead.
From here I'll speed it up a bit just to save some time.
One frag left.
I have to say that I'm pretty impressed with this machine's performance thus far.
Accuracy. Perfect.
Let's quickly take a look at the performance that the system had with the Matrox G450 as well as the Pentium Pro installed. These were the settings that I used. And this was the performance.
Ranger.
You should clearly be able to see the difference. I'm now going to run a time demo, but before I do so I'm going to disable the frame counter, as having the frame counter running does reduce performance slightly. That's not too bad at all. By the way, these benchmarks were run with the sound quality set to high. As far as memory goes, the system is a bit on the shy side, as it's only running 192 megabytes of RAM of the possible 768. and as far as I understand it, XP needs at least 512 megabytes of RAM in order to run properly. So what I'm going to do now is I'm going to run Quake 3 in a windowed mode using the standard GL settings with the system performance monitor open on the outside, just to show you the system's page file usage as Quake 3 loads and as it runs. Just watch that page file usage as the game starts. So it's already gone from 86.3 megabytes to 290 megabytes.
Ranger.
It's now peaking at 299 megabytes with 22 megabytes of physical memory available. It's now back down to 85.9 megabytes once the game is closed. So this shows that the machine makes use of a significant amount of page file space while Quake 3 is running. So I'm sure I'll be able to get some more performance out of the machine once I have 768 megabytes of RAM installed, therefore minimizing the page file usage. Hope you enjoyed the video and thanks very much for watching.